Bismillahirrahmanirrahim. In this video we will discuss about our project line following robot. Here now here is a block diagram of our line following robot. Here in this we use the 5 sensors. Here 2 sensors are the left sensor, here is the 2 right sensor, and here is the center sensor. This is the center line. The aim of this project is to follow the line or tracking the black line using the by using the logic circuit. It simply tracks the line and by the motor control, motor left and motor right control, it turns left and right. We draw the logic circuit here, and by using the L298 and motor driver, we made this project here. Now the sensor placement is shown here. Here we use the 5 IR sensors. One sensor is at the center at which it detects the straight path here, and 2 sensors are at the left side of the face which detect the left path to turn left, and the remaining 2 sensors are at the right side which detect the right path and to turn left. And now the next is here is a sensor logic. The first thing is to when the T junction comes in front of the sensors, then the robot will be stopped. When T junction comes and all the stages, all the sensors are almost show the one output here. Right and left both show the one output. It means the T junction is here and the robot stops. And when the central sensor and maybe central or the left sensors show the one output, then the motor left only works and the robot turns right here. And similarly here, when the left side and central sensor show one signal, then the motor right works and the left motor stops working and robot turn left. And here is a condition of the dead end. When all the sensors show the 0 output, the motor stop working. It means that when here is a dead end of this, here is a no black line, and all the sensors show the 0 output here, and it shows it stop working here. Now we go to the truth table here. Logic design truth table. In this truth table we define all the logic which we can perform, which we want to perform by this logic circuit. Here is a left motors, left sensors left, and here is a center, and here is a 2 right sensor. Here is a motor left, motor right here, and here is a junction shown, and here is the mean term of the motor left and motor right. And this condition 0 0 0 we previously discussed, it shows the dead end here. Here is a dead end and both the motors are stopped. Now here it is only the right sensor works. It means it turns right here, and the motor left works and it turns right. Similarly here, it right sensor works and it turns right here. And now in this condition only the central sensor works. It means that it has a straight line, then it go forward. And in this truth table only one condition is here, in which both motor left and motor right works. Now here we can see that the center sensor and the right sensor both are 1 1. In this condition the motor left will works and motor right will be stopped. It means that it turns right here. Similarly here, because the both right sensors have the same working here. now for the here we can see that all the sensors show the 0 output. Only the left sensor show the 1 output. It means that the motor right works and motor left stop, and then it turns left here. Similarly, here is the new case of the T junction. We can see that when the right and the one sensor of right and minimum condition is this: when the one right sensor and the one left sensor will show the output signals, then it show the T junction here. We can see that here is a one from the left sensor and one from the right sensor, which shows the T junction. Similarly here, one from right, one from left, one from left and one from right. And here we can see that the central and left show, it means it shows the left, it turn left here. Here is a T junction, here it turns left. Similarly, in all truth table we define the junctions here. We write the minterms of all the ones here. We take only ones here. We write the minterms of motor left, and here we write them in terms of the motor right. Now we using SOPs here, we sum all the products of the motor left here and motor right. We implement the circuit on the Proteus, but we can see that here is a huge amount of the ICs. It's become very hard to implement in hard form. So reducing for the reducing of the complexity, we use the K-map here. Here we draw the K-map for the motor right, using the sum of the products here for the motor right here. We put the number of ones here, and we make the groups of this. Here is a group of this red one, this and this. Here is a three groups where we write the equation. We can see that for the blue one, here is a C is 1 and R bar, R is equal to 0 0. We can write here C R bar R bar. Here we write C R bar R bar. For the red group here, we can see that here is a both 1 in this is I, and L is 0 1 here, which shows which is not the same here. Here we write I, and here for R and R we can see that here is a 0 0. We write here R and R bar. Similarly for the yellow group, here we write the L, R and R bar. We taking common L bar and I bar, we can finalize the equation here: L bar I bar R plus C. Similarly for the motor right here, motor left here, we draw the K-map of this, and here is also the same. We have the same equation here for the motor left. We can see here, here is the three groups. For here is a equation of the blue group, here is a for yellow group, and here is a for this group. Here we take the common and L bar I bar, and we take the equation. Here is a mistake here. Here we have to take the common R and R bar here, and the finalized equation is R bar into L plus I plus C. So after this we have the two main questions here. F of motor left is R bar R L plus I plus C, and here is for our motor left L bar I bar into R plus C. Here is a logic diagram of this circuit. We have implemented this on the Proteus. Here is a 5 sensors, and here is a circuit of this motor left, and here is a for motor right. Here right sensors. Here we use the L298 motor driver. Here is a motor left and motor right here. Now we simply test all the cases here. Now we can see that here is a left sensor showing a signal 1 and center. When any one of these three shows the signal 1, and then the motor right work. When there is a dead end, then both motors are the stop. When the only center sensor shows the 1, then both motors are working. When here is a from 3 sensor, any one of these sensors will be 1, then the motor left will be on. There is no change in this. And when it's a condition of the T junction, when any one of the sensor from one side right and one from right side and one from left side, then the motor will be stopped. It shows the condition of the T junction. After this we go to the here where we connect the 3-pin connector to draw the PCB. We connect the 3-pin connector to the all the sensors here. Here we connect the for VCC and ground here, and here we connect the motors output here. And for the PCB design, here is a PCB design. Here is a 3 by 3 inch PCB board here. Here we have the 3 ICs here, and these are the 5 sensors: J1, J2, J3, J4 and J5. Here is the motor's output, and here is a ground and VCC. Now here we have the 2-layer PCB, but we have drawn it on 1 layer. The second layer is for the second layer we use the jumper wires here. After this we print it on the sticker sheet, and we draw it by the pressing on the board, and after etching we drill the holes here. After holding we solder the components on the board here. After this the final result is here. Here is the final result of this. We can see that the board is following the line perfectly. Now for the second, we perform this from the both ends. We can see that here is from right to left. That is the output of this. We use here in this project the L29 3D motor driver module, and the specification of the module is that it can run it have the input voltage 12 volt, VSS power supply 6 volt, separate input logical supply, and it can have the input voltage from it can bear that input voltage from 12 to to 24 volt, and it also can give the output from 6 to 12 volt. It have the ampere current from 1.2 ampere, highest input. And here is the specification of the IR sensor module. The operating voltage of the IR sensor is from 3 volt to 5 volt. The detection range is the range at which it can detect the object is 2 centimeter to 30 centimeter. We can adjust it by potentiometer on the IR sensor. We can see here. Here is a potentiometer. By rotating this, we can set the range of this. Here is a emitter and here is a receiver. It emits the radiation and it receives the radiation. Now here above, that's all. And here is a pin configuration of the IR sensor. It has 3 pins, VCC, ground and output. Here in this picture we can see that here is a VCC, ground and output 3 pins, and these are the 2 LEDs which shows the input and output signals, and from here with the potentiometer we set the range here. Here is a pin configuration of the L293 3D motor driver here. Here is a we can define from this. Here is a motor driver for output of motor 1, and here is a output of motor 2 here. And here is a input VCC. Here is a ground pin, here is a 5 pin input, and here is a 12 pin input here. That's all for this motor driver. These are the objectives of this, and the final result is here. The main thing we learn from this is how to design our own logic circuits by their own thought. As we design here the circuit of the 5 sensors here, using 5 sensors. Here we design here our own logic circuit. We know by learning from this we can design our own logic circuit which can perform any of the given function here. As here by using the truth table as we defined here. That's all for this report project.